Welcome to a new video on my Raspberry Pi 3 in combination with the PiXtend PLC, which I completely built myself with existing parts, of course. Connected to a breadboard with some basic electronics. The idea is to control communication and devices, where LEDs are also devices, motors which are currently not attached are also devices. Raspberry Pi runs a special version of Raspbian Linux, suitable to control the PiXtend PLC, programmable logic control. Recently I dived into several things. Serial communications through RS232 right here. Also digital output, digital input, what works, what doesn't, and some surprises that voltage levels were quite low. And to get a better idea of what this board capable of, I have made I've completed schematics, which makes it all a little bit more clear. So before going on, let's take a look at that one. So running from the Raspberry Pi, I have here the VNC desktop terminal, and I've done a little bit different thing. So far I've used Python version 2. Now I'm using 3.5.3, but I didn't rewrite my code. So the question is, will everything work? And well, here you can see the power supply that powers the Raspberry Pi, or no, it powers the PLC, but through that, yes, it does power the Raspberry Pi as well. Anyway, this is Minicom again. Set to normal speed. SSH connection to make sure that I can actually start the VNC server. Then what I said about the schematics. So relay 0 to 3 or 4 relays, digital output, pulses modulation, and previously I was under the impression that it was either or, but they are both. So digital out 4, pulses modulation 0, digital out 5, and pulses modulation 1. Digital input, and here I corrected something, because I put this or one of these connectors here, but when you have 8 digital inputs, you really do have to use 8 connector with 8. So 1 through 8 is the same as 0 through 7. Also added the connector for GPIO, general purpose input output, analog output, and analog input. So that is very nice to measure. I should be able to measure a voltage here. Question, will I? Well, I can program it and then see how things develop. What I also did was adding the Visdenic diode LED actually. Yeah, it's an LED, so I should change this. It is a diode, but light emitting diode, so it's an LED. And this part of the connector I changed as well. The RS interfacing, currently commonly known as EIA, but for communications RS is still used. So 232 and 485. 85 is a lot used in industry. Anyway, let's see how I can do this programming analog output and see whatever it brings. Alright, now I have, as you can see, added to the screen the oscilloscope. One wire here and one wire here, connected to analog output 0 and 1. Now, how do I engage it? How do I set it? Well, of course, looking at the Python package for the PiXtend, I realize it's not real. It's not just analog output. It is digital because the computer is digital. So how do you get analog? By conversion. A digital analog conversion. And then you have DAC selection is DAC A, etc. So how does it work? Well, that's another point. Okay, let's do it like this. I have now put it in this one, copy the text exactly. So I have to save this and now run it. And then it will only happen. Oh, that's a good one. Let me quit this, because it is very nice if I can tell myself that I am watching at analog output now, and it is DAC A, digital analog conversion A, and then this would be needless to say B. Now I can do something, whichever it may be. So I'm very curious what this will give, and I may have to, okay, that is quite different, and let me put another one to ground. And select channel 1. Okay. Select channel 2. And this is an oops. Oh, this is for SPI apparently. Yes, it is for SPI, so it's not okay. Well, it does not say it is for SPI. Oh wait. Inputs and outputs, analog and digital in the microcontroller via the Raspberry Pi's SPI bus. Okay, so it is the SPI bus from the Raspberry Pi. So that doesn't really matter. What I want to do, see, because this is SPI, open DAC. So I clearly have to do open digital analog controller. Right. Before you do anything, read the manual. But then again, I'm an engineer, so I tend not to read the manual. Anyway, clearly I need to copy that one. Go here, and then I want to actually set anything. Yeah, let me do it here. If this works out, maybe not the best way to do it here. This is all serial. Everything about serial. But you have to open it only once. So that's a bit... Okay, let's do it here. Why is it gone? Okay, open doc. And again. Right, let's do it again. Go here. And go. Open deck not defined. Really? Okay, time to find out more. Alright, changing the code a bit. So now I have print DAC analog output, which does do tell me which it is. 0, which turns out to be the digital converter A. So then I want to say, right, then set the output to 512, and then I will see which one it is, I hope. So let's do that. And whatever happens, happens. Should not take long. Ah, look at that. But, oh wait, that is in both. Alright, kind of interesting. Let me change the time scale. To half a second. Do I see anything in particular then? Yeah, but for a long time. And these are different signals. Okay, I have to increase the time base. No, this is voltage. I'm changing the voltage. Wait a minute. This is changing time base. $50 milliseconds. Okay, let's say 50 milliseconds. How does that go on? Okay, too fast. No. The other way around. Back to 1 second. Okay, and now to half a second. But apparently both probes are now connected to converter A. So in a sense I could say that that does work. It just needs improvement because this is not all it should be able to do. And that is, I guess, it for this time. And with this new experiment for analog output, I say thank you for watching. Just another look at the oscilloscope. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, please. Much appreciated. You can also follow me via Instagram and Twitter. And you can please support me via PayPal or Wired. You can also become a patron. And may mentioned depending on the pledge you make. For now, this is going to be continued. Please see also my website, which is listed under this video and in the segment coming next. To be continued. Have a nice day and bye bye.